Alright everybody, so this check-in activity is supposed to be in the style of Just a Bear. Did you get it? Winnie the Pooh? Alright. So if he's pushed forward while walking with an equal amount of force as the force on him backward, those are balanced forces, right? So, Newton's first law, are y'all paying attention here? Newton's first law says that an object at rest will remain at rest, and an object in motion will remain in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So this thing has balanced forces. That means it's not going to change its speed or direction. So if it's not going to change its speed, it's going to have a constant speed. Whether it's at rest or moving, it says this guy's walking, so I guess it's walking. But if it's at rest, that's still a constant speed. It would be stay at 0, and it'd be 0 the whole time. That's constant. But whatever speed this guy's walking with, balanced forces aren't going to accelerate him. So constant speed. And these, if you answer them, they will give you a little explanation with the answer. All these this week are designed to help us prepare for the CTBA, which is in not that many class days, on December 10th, Thursday. I guess I think that. So, if you guys want to write this down, we got the CTBA schedule here. Huh? Oh, right here, huh? There, CTBA schedule. See all of that, right? I think that's all there is. Anybody want to take a picture? Alright. Well, so we're going to talk about energy next here. Let's see. This one, yes. Energy. This is going to be a lot easier than what we were doing, so good. Yay, hooray. Before I go on though, make sure that if you got a 60 or below on the last test we took, that you retake it. If you consistently get below a 60 on those tests, your other grades won't be able to bring it up as much. You'll end up failing, and you'll fail multiple times in a row, and then that'll potentially stand in the way of your graduation. So be real careful when you take tests and you get a low grade. Contact the teacher, in this case me, to retake your test. And I know some of y'all did well, so that's good, but just in case. Let's see what we're gonna. Energy. Y'all know what energy is measured in? Yeah, like quiet. That's force. I like that you're talking though. Good. Some people are just quiet and they don't say anything. It's joules. Joules with a J. Joules. Made famous by Charles Dill. French guy. So, we can have many kinds of energy. Y'all have heard of kinetic energy. When things move, they go woo. When they're moving, they have kinetic energy. We can also have potential energy. Like y'all have potential energy right there. Where else? Here. Anything with a battery has potential energy in it. It's got chemical potential energy. My bus here has potential energy. I can wind it up here, it'll stay all day. I've got stored energy right there, but it's all wound up. So, what do you think you would call this potential energy before I let it go? I mean, it has the potential to do kinetic energy. That's what's potential energy can be turned into many forms, but often it's kinetic energy. But it's not kinetic. I know we moved it to get it stored up, and so that would make kinetic energy has something to do with it for sure. I would call this, because what's in here is there's a little spring in there that's getting compressed, and then it gets it lets go slowly as it goes. So I would call this spring potential energy, or the official name is elastic potential energy. because it gets stretched out. So like that way a rubber band also works. Rubber bands or springs are elastic potential energy when they're all pulled back, like this guy. Okay. And another thing, we can have gravitational potential energy. So I can put this guy right here and see if he falls. He broke my pencil sharpener earlier, so we're going to make sure it doesn't fall. Poor little pencil. Well, this is gravitational potential energy. This guy has the potential to fall down. People actually use this to generate electricity. So what they do is they take a big old crane and they have a bunch of solar panels. And the solar panels power the crane during the day. Some of the electricity is used for like the community or whatever because it's making electricity, everybody gets to use it. And then the crane uses part of the energy to start stacking up these concrete blocks. So it takes them and it stacks them up, takes them and stacks them up, takes them and stacks them up. It makes a big old tall tower with them. And then when the sun goes down, or when it gets cloudy or whatever, maybe you've got a sandstorm and you've got to clean off the solar panels before they work, it takes them off the top and it's got a generator attached to its little rope, so as it lowers it down, it spins the generator and makes power that way. And that's actually a thing. People do that with, it's a gravitational potential energy power plant. Kind of neat. So yeah, we can actually calculate how much gravitational potential energy this guy has. It says 200 grams on it. So it's got a mass of, let's see, there's 1,000 grams in a kilogram. So if that's 200 out of 1,000, that's 0.2 kilograms. Our formula for potential energy is, our formula for gravitational potential energy is mass times gravity times height. M for mass, G for gravity, H for height. PEG up here is 3 whole letters for one number, which is kind of silly, but it's 3 words, gravitational potential energy. It tells us what kind of potential energy it is, and the potential is what kind of energy it is, so it's got 2 adjectives and then the real thing it is. So we could just say E, PG or something like that, but that's not what we do. We say PE for potential energy with the G for gravitational potential energy. Anyway, what do we say? 0.2 keys for the mass? 0.2 keys. What about G? What do you think G is? Nobody has a guess? G is gravity. What number do you think we use? Negative 9.81, yeah. Good guess. I know we haven't seen that before. But yeah, same as what we've been doing with gravity, is that negative 9.81 number. And H is interesting here because this guy, does this make anybody else nervous? Like, you can see that this thing has potential energy because it's up there like rolling around. It could totally fall at any time. So we're going to calculate how much energy this thing would do if it came down here and smashed my toe. That would hurt. I'm glad I'm wearing closed-toed shoes today. See? Okay, well. What am I doing? Oh, the height. Let's say this thing is 1.7 meters tall. However, anytime you use this formula, this PE/mgh, H has to be negative because this guy has the potential to fall in the down direction. So we will say negative 1.7 meters. 1.7 negative. And then if we multiply all those together, let's see, I wrote my formula. I'm rewriting it with 0.2 is M. What's next? G is negative 9.81. And H is 1.7. If I multiply all these, it gives me 3.3 joules. And joules, just so you know, is Joules. Joules, like that. I guess circle everything. So there's an example, calculating potential energy. And I'll do one more example. This is kind of a trick question. Let's see here. So this is actually one of the questions on one of the assignments. I don't think it's... This is one of the questions on one of the assignments. It says it's a 1 kilogram pineapple under the sea. I wonder what Mr. Franklin's trying to say here. That's weird. 1 kilogram pineapple under the sea, whatever. It had a gravitational potential energy of 0 joules. Well, that's a... Why would it be 0 joules? I guess it's under the sea. Did you guys bring cans today? No cans? No toothbrushes? No toothpaste? Oh, man. All right. It says, what was its height? Okay, it's asking for h then. I'll say h equals blank. What am I missing? Oh, g. G is negative 9.81. All right, so I'll do one of these here. Here's my formula. It gave me the potential energy, 0 joules. Have you all already figured this out? If it's got 0 joules of potential energy and it's asking for h, some of y'all may have already figured out what h is. Let's see. Got a mass of 1 kilogram, and g is negative 9.81, and so 0 equals this times h. So what do I need to multiply this and this by to get 0? It's going to be 0. If it has 0 joules of potential energy, that means that if it falls, it's not going to hurt anybody because it's not going to fall. There's no. If it fell this far, it would have a little bit of potential energy, but it's not going to fall. Anyway, we can still do algebra with this. So 1 times 9.81 is 9.81, and if I pretend that this already says 9.81, then that's fine. Here, I guess I can do that, and then I divide this side by 9.81. 0 divided by 9.81 is 0. Oh, it's not joules anymore. Sorry. That's h, so now this is meters. So, all right, and that's 1h. We don't have to write the 1 since I didn't cancel it up there. That's fine. And there you go.